Yes, it's working. Okay, so where do we start with this one?
I was going to suggest 1 plus tan t, but
right. Yes, I want to look at two situations here. 1 plus tangent t, because it's in the denominator. I'll explain in a minute. So we're going to compare two substitutions. And the other one I'm going to denote it by y, not to be confused. Okay, so let's say we want to compare C if both work, and which one is shorter. Okay, let's get the easy one. dy equals, can anyone give us dy?
That's secant squared t dt.
Brilliant. Okay, can anyone give us du?
That's secant squared t over 2 the function. I just put the thing on top.
Okay, perfect. So you already did that. Excellent. So
yes,
perfect. So we have the square root of a function prime, which is 1 over 2 the square root of that function, times the inner function prime, secant squared dt. Okay, so I'm going to continue with this. But we do know that secant squared has another way of writing. Is there another way of writing secant squared? Or secant itself, first of all, if that's what you want first.
Tangent squared plus 1.
So secant is the same with 1 over cosine, right? So secant is 1 over cosine. Secant squared is 1 over cosine squared, correct? Is that okay? We remember this identity? Is that a yes?
Yes.
Yeah, we remember that secant squared is 1 over cosine squared. And let's look at what we have here for a moment. I have secant squared, which I will replace by cosine 1 over cosine squared. So then du equals dt over 2. Instead of secant squared, I put 1 over cosine squared. And the square root of 1 plus tangent t. Let's go back to our integral, and I'll come back to the other option in a minute. Let's go back to the integral. Du is dt cosine squared, the square root. What am I missing? A poor 2. Huh. Multiply the top by 2, multiply the bottom by 2. Not a big deal. So 2, what does this get replaced by?
du.
Can it be easier than that? So then, what is this? Which function prime is 1?
X.
Yes, but u. Very good. Awesome. So I just have to replace u by that. Let's see what we get with the other option by comparison. Okay. Any questions on this? Let's say for the sake of the argument that I consider just the inside to be replaced by or use a substitution for. And we decided that this is the case. And of course, I have to rewrite dy as 1 over cosine squared dt. And let's see what happens now. I'm going to have to start from scratch. I cannot write over there anymore. because that belongs to the first option. So our integral was dt over cosine squared t, the square root of 1 plus tangent t. And now we have dy, which is dt over cosine squared. This is the dy. And this, obviously, is y to 1/2 in the denominator. So then the integral becomes dy over y to 1/2 or y to negative 1/2 dy, which is y to negative 1/2 plus 1, which is y to 1/2 divided by 1/2 plus a constant c. Flip to the square root of y plus a constant c. I have to go back and replace y, and that is the square root of 1 plus tangent t plus a constant c. It doesn't really matter. I would go with this because it's shorter, but not a big deal, not a big difference. Good pick. Very good pick, actually. Now, I would like to talk about definite substitution rule for definite integrals. And then we'll go back and practice more. Here they are. So 59 through 80. Allow me to choose the first one, and then you will choose the next one. All the next ones if you want. I'd like to start with 65. In 65, we have the integral from 1 to 2 from e to 1 over x squared dx. I like this one. Okay, so like before, the only difference is that this has limits of integration. It's a definite integral between 1 and 2. The first thing is a definite integral and make sure that the function is defined and continuous. Yes, it's continuous between 1 and 2. There is no problem here. There is no problem here. The only problem is when x is 0. 0 is not in the interval. Safe. Good. So now let's decide what we would like to use. What bothers you, so to speak? And we had a similar example when we started.
The 1 over x.
Indeed. As long as du is in the problem. Awesome. Brilliant. So can anyone give us du? Someone I haven't heard from today. Anyone? Oh, Sean, I'm sorry. Go ahead. If you want to.
Nope, changed my mind.
Okay. That's okay. RJ, Janelle, Christine. Who would like to give us du? Are you with us? Anyone?
I'm here, but I don't have an answer for you.
Okay, that's okay. Anyone would like to help? Gia, go ahead.
Ln of x, absolute value of it.
Yeah, that is the confusing part. So here we're differentiating. Okay? So maybe I should just do this. Okay? Here we're differentiating. So this is the differential of this function. I know You see the integral and you may be interested, you may be tempted to integrate, but that's not what we're doing now.
Oh, it's on the -1.
Exactly, over x squared dx.
Yeah.
Indeed, yes. So I know it's confusing when you see these two together, you see the integral, but then I'm really asking you to differentiate. I know it's till we get used to it. I understand. Good. No problem then. I have 1 over x squared. I have dx. This is the only thing is missing. Who cares? I can multiply by -1 twice. So I have a negative in front now. Do not copy the limits of integration, but tell me what I should write. E to what?
1 over u.
But we said that 1 over x was u,
Oh,
right?
e is u, sorry.
Yes.
E is u, sorry.
E to u, and then negative 1 over x squared dx, negative 1 over x squared dx. What do I replace this by?
du.
Exactly, awesome. But now careful. These are the limits of integration for x. You cannot simply copy those, transfer those to an integral in u. You have to determine the limits of integration. When x is 1, what is the lower limit for u?
0.
We can have 0, right? It's 1 over 1, right? When x is 1, 1 over 1 will be the limit of the lower limit for u, correct? Is that correct?
Okay, so it's 1.
Good. So now what if x is 2? What is the upper limit?
1/2.
Exactly. Excellent. So now I'm going to put a circle around it and move on to the next page. So I'm just going to copy that here. I mean, I don't need to. So it's e to u from 1 to 1/2. Keep the negative outside. E to 1/2 will be the square root of e minus e to the first power. That will be e. You can distribute that sign if you want, and just write e minus the square root of e. So what is different? The limits of integration cannot be copied. You do not have to go back to the previous variable. We do not do that. Please don't. No matter what they show you other places, please don't. Because you cannot write this integral with these limits of integration. You have to find the limits of integration anyway. The answer is a number. You cannot check anyway unless you plug it in the graphing calculator, right? So why go back? Please don't go back. You have new limits of integration, and the answer is a number. You will obtain the same number if you integrate with respect to x or with respect to u. With respect to x between 1 and 2, and with respect to u between 1 and 1/2. Now, if you want to, for the definite integral, you can check with the graphing calculator. There is no need, but we can. So let's do that. So we have from 1 to 2, and of course dx, and the integral is e. Where is my e? E to 1 over x and everything divided by x squared. Oh, it's going to give me whatever number. And then I have e subtract the square root of e. And this has to be exactly the same number. Where is my e? Right here. Okay? So it has to be the same. No question about it. Okay? Good. So let's practice. Now feel free. I don't know why I stopped. No, that's not it. I don't need this. I need this. Okay. It's up to you. I'd like to look at 67, but not yet. I mean, we can look at 60, but I want to practice some more. 67, if you look, it's on a symmetric interval, and this is an odd function, so the answer will be 0. So there is nothing about substitution here. There is no substitution that needs to be applied. So let's focus on the substitution. Anything else you'd like to pick? What about 75? 75 we have from e to the 4th, from dx over x, the square root of natural log x. Okay, ready. Where would you like to start with? Any suggestions, anyone? Well, I would start, yes, go ahead.
I was gonna say the square root of ln x, but
Okay, we can start with that, or we can start with just this natural log. We can do both. That's fine. Let's do that if you decided to do that. Good. So can anyone give us du? And let me cover this. We're not integrating. We're finding the differential of u. Yes? Anyone?
Is it 1/2 ln x to the negative? Oh, yeah.
So 1/2 the square root times the inner function prime.
1 over x.
Excellent. What else? Because if I forget this, I'm in big trouble.
Dx.
Excellent. So now let's take a look. Let's see what we have and what we don't have. So 1/x I have. Dx at the top I have. The square root of natural log x I have. This is the only thing I don't. Really? I multiply and divide by 2. So now what do I replace this by? What do you think? It's okay if you're wrong,
du.
of course. However, I have to determine this, and I have to determine this. I cannot continue. I cannot write that these two are equal before I change the limits of integration. So if x is e, how much is natural log e?
Is that 1?
Good. How much is the square root of 1?
1.
Thank you very much. So now when x is e to the 4th, how much is natural log e to the 4th?
What's your question again? I'm sorry.
So when I plugged in e, I determine the lower limit. Now I have to plug in e to the fourth in x to determine the upper limit for u. So natural log of e to the fourth, I bring 4 in front, so I have 4 natural log e. How much is natural log e?
Goes 4 times 1.
1 times 4.
So
How much
4.
is the square root of 4? 2. Great job. So now from here, I have 2, which function prime is 1. Yes, yes, but I have to use the variable, right? Between 1 and 2, very good. So 2, 2 minus 1, 2 minus 1 is 1, 2. Careful, these become a little bit cumbersome to plug in the graphing calculator. You can, but be careful with all those parentheses, etc., because you can plug in and then you're going to start spending time on trying to match this with that. So be very careful. This is not easy to plug in my opinion, anyway. So e to the fourth, and that's dx, and it's 1 over. Be careful how you plug this in. It's again, it's not easy. 1 divided by, you have to have parentheses around the denominator. So it has to be x, it has to be the square root. With or without here, that's not required necessarily, but be very careful. Put enough parentheses, because otherwise the calculator will give you something insane. And you're going to start spending time, especially in the tests or finals, start messing with this, and it will take you a long time. So be very careful with this. This is not easy to plug in. Okay, perfect. So let's continue with anything else from definite integrals. So what is the difference again? So allow me one more second. What is the difference? When it comes to the substitution and the differential and changing from x to u, there is no difference. The only difference is you cannot say that this equals that without the appropriate limits of integration. E and e to the fourth, if you copy them here, the whole thing collapses. You cannot copy these. These are for x. But now you have u. So you have limits, you need limits of integration, the lower and the upper. For u, when the lower limit is e, we get 1. When the upper limit is e to the fourth, we get here 2. And that's how we proceed. That's the only difference. Okay, ready. Anything else you would like to choose?
Uh, 80.
Okay, very good. So let's look at 80. So the integral from 1 to 16 from x to 1/2 over 1 plus x to 3/4 dx. Good pick. This looks awful, initially anyway. Good.